In this video, we'll cover lists, tuples, dictionaries, and sets. In the previous video, we spoke about variables, data types, and indentation. But we just got started with the data types. We worked on the numeric types, text types, and boolean types. Today, we'll get an understanding of list, tuple, dictionary, and sets. List is an ordered sequence of items. It's one of the most used data types in Python and is very flexible. All the items in a list do not need to be of the same type. Declaring a list is pretty straightforward. Items separated by commas and enclosed within square brackets form the list. The index starts from 0 in Python. This may be confusing for people new to programming. The first element is referenced as 0, the third element by 2, and the ninth element by 8. Here, we define a list with multiple different types of values. If we print the type of A, we get the class list. We can use the index to reference and get the values in a particular position of the list. For instance, the 0th position has the value 11 and the second position has the string Python. Next, we are learning about slicing in lists. The slicing concept is similar in Python strings as well. When we slice, instead of providing one value, we provide two values separated by a colon. Let's take this example list which starts from 1 and goes through till 9, and this chart provides us the values of the indexes that we can use to reference those values. Note, there are also ways to reference this using negative numbers. The slice operator returns a part of the string. It starts from the first value of the index till the last value of the index. The first value of the index is inclusive, while the second value of the index is excluded. Isn't that pretty confusing? Let's take a look at an example. In this example, the values 1 through 9 are referenced by indexes 0 through 8. So, for instance, the index 0 would indicate the value 1 and the index 7 would indicate the value 8. So when we slice this from 0 through 7, we take all values from 0th index until the 7th index, but we exclude the 7th index. So it goes on from values 1 through 7. The negative index values refer to the position from the last. So for in this instance, when we have to look at values starting from -2 until the end, it looks at the values that start from the second last position and go on until the end. So the value would output the last two values, 8 and 9. The next slicing we're going to look at starts at position 0 and ends at the second last position. So the position 0 starts with the number 1 and the position second last ends with the number 8. As the second last position needs to be excluded, we result with the value from 1 through 7. Let's look at the next example where we slice from -5 until -1. So the -5 denotes the fifth last position, which is actually 5 in our case, and goes on until the first last position, which is until 9. And given that the second value needs to be excluded, we result with the values 5 through 8. Let's do one more example where we start from -1 and go until -5. In this case, we start with the last position and we go on until the fifth last position, which doesn't make any sense to Python. That's why it returns an empty list. Let's look at an easy example again, just to refresh our minds. In this case, we're going to look at index values 1 through 5. Remember, this is the index value and not the absolute position value. So the index value of 1 would reference the value 2 and the index value of 5 would represent the value of 6. And the second value would be excluded. So this result would throw values from 2 until 5. What happens if we just use a position and use the same position as the end value. For example, A slicing 1 until 1 does not return any elements and is an empty list. Lists are very commonly used in Python programs, and one concept that makes them really important is that lists are mutable, meaning the value of the elements of the list can be changed. In this example, we have a list with values 1 through 9. We want to change the second element and change it to be a different number. Now let's try printing it out. This is the right time to talk about tuples. Tuple is an ordered sequence of items similar to a list, but the difference is that tuples are immutable. Tuples once created cannot be modified. Tuples are used to write protect data and are usually much faster than lists. Even though lists are much more commonly used in Python programs than tuples, interviewers love to ask questions about tuples. So let's understand them clearly. Tuples are ordered. That is, they are part of sequence data types. They hold the order in which data is inserted into them. They have an index, and each value can be referenced by the index value. The next important concept of tuples is that they are unchangeable. You cannot add values to the tuple, delete values from the tuple, or change the order of the values in the tuple. They're heterogeneous. That is, they can have things like integers, floats, a list, a string inside them. Lastly, unlike sets, they can contain duplicates. Recently, one of my students was asked in an interview to write a program to add an element to the tuple. There are no built-in methods to add items to the tuple. My solution was to convert it to a list, add the element, and convert it back to a tuple. Do you know a better solution? Share it with others in the comments below. Let's try playing with some tuples here. Here is a string tuple with 3 different values. We define the tuple by using brackets. The next example is a mixed type tuple where you have strings, integers, floats, and lists as a part of the tuple. In sample tuple 2, we use the tuple constructor to build the tuple instead of just using the brackets. Let's try referencing one of the elements of the tuple using the index 0. Tuples we know are immutable. When we try to reassign a value of a particular element of a tuple, Python throws the type error. After lists and tuples, the next item on our agenda today is sets. Set is an unordered collection of unique items. Set is defined by values separated by comma inside flower braces. Items in a set are not ordered. We can perform set operations like union, intersection on 2 sets. Since sets are unordered collections, indexing has no meaning. Hence, the slicing operator does not work. What if I define a set with multiple duplicates? Here, 2 and 3 are duplicates. When I try printing the set A, I get the non-duplicate values only. If we try referencing it by index, we get the type error with the message that set object does not support indexing. Let us use the set function to convert a list into a set. Now let's use the add method to add an element 300 to it. We can also try using the remove and see what it does. The last item on this lesson's agenda is dictionary. Dictionary is an unordered collection of key value pairs. It is generally used when we have a huge amount of data. Dictionaries are optimized for retrieving data. We must know the key to retrieve the value. In Python, dictionaries are defined with flower braces, with each item being a pair in the form of key and value. The key and value can be of any type. In a dictionary, duplicate keys are not allowed, but the value can be duplicated. If we try to insert a value with a duplicate key, the old value will be replaced with the new value. Today's assignment is to write a program to use a numeric list to remove duplicates and order the data in the list in an ascending order. If you need help with the assignment below, let us know in the comments, or you can look at the solution in the link below.